Hi everyone, Lloyd Rieber here again with our next example of using Excel to compute some statistics. In this video we'll use Excel to compute a correlational statistic, namely a Pearson Product-Moment Correlation Coefficient, or Pearson R for short. A reminder that I will talk rather quickly, so be sure to use the pause and rewind controls as needed. And a reminder also that I'm using the Macintosh Excel 2011 version, so if you are not, then you'll need to translate my actions for the particular version you are using. All right, let's get started. Recall that in the last Excel tutorial, we imagined giving a group of 10 students a survey of their general attitudes toward online education. Now, let's suppose that these same 10 students just completed an online course with me as the instructor. Sounds familiar. Let's further imagine that I asked these students to complete another attitude survey, but with questions specific just to my course. Now, I'm curious if there's any relationship between the students' general attitude about online education and their opinion of my online course. The scale of the course survey ranges from 0 to 40, just like the other survey, with a total of 0 being an absolute dislike of my online course, and 40 being the most positive attitude of my online course. First, you need to launch Excel. If you haven't, pause the recording and do so. Next, let's open the Excel file we created and saved last time. Recall that its title ended with descriptive 2 and was saved in a folder called descriptive statistics. Okay, I'll go up to File, choose to open, and you can see that I have a little Word file in the background that we will be consulting in just a moment. So there it is, descriptive 2, Rieber-descriptive 2. Let me go ahead and open that. There we are. Next, let's immediately choose to save the spreadsheet, but with a different name. We'll choose Save As from the File menu and change the spreadsheet's title to the following. So Save As, and again I'll leave my name there. I'm going to change it to dash correlation. Now I have created another folder called correlational statistics, and I put it in the folder for the course. So I want to make sure that I save this file in the new folder. Here we go. So next we need to imagine that we gave the second survey and we have their scores. And we need to compute everything we did for the first survey. We have to compute the deviation score, we have to square that, and then we have to compute a z-score. Now we can do it all again from scratch, and there might be some value in doing that because we would even learn this better, but I prefer to let Excel do a lot of the work. So I'm going to do the following, and I suggest you just watch this part first before you do anything. I'm going to highlight the entire area of my workspace. I'm going to choose to copy. Then I'm going to come over to the next cell in exactly the same starting row. I'm going to choose paste. Now everything looks okay. I still have the same scores, so I have the same mean and standard deviation and the same z-scores. But there's actually a very small problem that I need to fix. For example, if I click on the first deviation score, 6.1, and go up to the formula and just click once, you'll see that indeed it's using the score that is in column G, but alas, it's using the mean back over here in column B. And you probably know why, because I made that an absolute reference to that particular cell. Now in hindsight, what I should have done in the very first video is not put dollar signs in front of each one of these two elements. It's just a habit that I have when I'm using Excel. I when I make something an absolute reference, I just go ahead and put in the $ before each of the two elements. What I should have done is simply put the $ in front of the 23. The B, I would like it to be relative, and it only makes a difference now when I'm going to be copying and pasting the scores over here on the right hand side. So I suggest that we bite the bullet, and before we do any copying and pasting of these scores for us to then change and update, let's go ahead and make this change to the absolute value that we have here over not only in column C, but you'll also notice here in column E, where the z-score was computed, we did the very same thing. So if I come up here and click, you can see that I'm going to be taking from the standard deviation here in D26, hit the X there, and indeed if I go over to this z-score, click on the formula, once again you see it's taking that standard deviation when it should be taking the standard deviation over here in column I. Okay, so let me undo all of my pasting there. And this is where now you should go ahead and start working with me. So let's start with the deviation score in column C, the very first one. And we're going to go up to the formula, and we're going to take away the very first $. That way column B is going to be relative. All right, you got rid of that. Go ahead and press return. So now what we'll do is just do the fill down technique. Click on that first cell, drag down, go up to edit, and choose to fill down. Let's do the same thing over here with the first z-score. Click on it, go up to the formula, delete the first $, press return, and then again click on it one more time, click and hold, drag down to all the values, go up to edit, and choose to fill down. Very good. That was an important step, so let's go and save the file. Now let's go ahead and copy and paste this entire set of data and calculations. So again, select the entire block there, choose copy, go to the very next cell in row 9, and then choose to paste. Excellent. Let's check things out. Let's go to the first deviation score, click up in the formula, and we see now, excellent, that 34 minus the mean. Let's go back up here, click on that little X to exit out of the editing of the formula. Let's go down about halfway to the 2.10, go up to the formula just to double check. Again, excellent. We're taking that score minus the mean of this data set. All right, click on the X. Do the same thing for the z-score. I'm going to click on the third one maybe. Go up and check. Very good. And I'll just do one more. Excellent. So I apologize that I didn't catch that in my first video, but on the other hand, this was a nice learning opportunity to see how Excel works, so I don't regret anything. Now the next step is to put in the scores of the second survey. So just be sure that you enter exactly the same scores that I do. So looking at student A, 38. Next, 22. Next, 36. I'm just pressing return after I enter each one. Next, 40. Next, 32. Next, 31. 43. 36. 29. And 37. And take a moment and make sure that your scores match mine exactly then go up to File and choose Save. Next, it might be helpful to do some labeling to remind ourselves of which data go with which survey. So I'm going to come over here to column A, row 8, and just type General Survey. Press Return. Come over here again to row 8, but in column F, and type in Core Survey. And one last thing I'll do, which I think will really help to distinguish these visually, is I'm going to go up to the column header, click and hold on F, go all the way over to Z, then I'm going to go over to the fill color. I'm going to choose a nice color. Just a nice light blue is what I like. Nice. So now it's very easy for me at a glance to see the two sets of survey data. Do a save. All right, it is now time to start doing some computations in order to compute our Pearson R. Let's take a look at our formula. So we have that R is equal to the sum of Z sub x times Z sub y divided by n. N refers to the total number of pairs of student scores. So in our case, n is 10. Now what about this Z sub x, Z sub y? Well, the x simply refers to the first set of data, and the y refers to the second set of data. So the idea is we're going to take each individual person, take their z-scores from both sets of data, and we're going to multiply them together. And then we're going to sum those up, divide by n, and that will give us R. Okay, let's see how we do this. I'm going to go to row 10 in column K. Row 10 is the same row with all my other labels, and I'm going to type ZX times ZY and press return. Now I can't do the subscript, so it really looks like I'm doing a weird multiplication there. So just remember that that's a label, Z sub X times Z sub Y. And the fact that I did not put an equal sign in front of it tells Excel to treat this as a label. Let's go down now to the first row of z-scores. And what we'll do is put in an equal sign because a formula is coming. And I will click on the first z, and then asterisk to multiply, and then the second z, and press return. And we'll do rounding later. But very good. Now we can use the fill down trick. Click and hold on that first, drag all the way down to the last, edit, fill down. And let's do another save. Yeah, let's go ahead and do some rounding while we're at it here. So I'll click on the column header K, go up to Format, choose Cells, go to Number, and choose the category number, and 2 decimal places sounds about right. Excellent. Let's check our formula again. So now what we need to do is sum all of those. That's easy to do. Let's go down and let's put in a label. As you can see, I have the same row as my other labels. And now the sum, equal sign. I'll just start typing. So sum, and then the open parenthesis. I'm going to choose the range, so start there, click, hold, and drag down to the last. Don't forget your close parenthesis, and then press return. Excellent. Okay, I think we're ready to compute R. So I'm going to come down right about there. So I'm coming down to row 29, which is far enough down below, which I think separates this out nicely. I'm just going to type the label R, press return. Now what is the formula for R? Well, let's go back to our formula. So you can see that we now have both the numerator and the denominator in our spreadsheet. We have the sum of the products of each person's two z-scores, and we have n. So all we now need to do is divide the numerator by the denominator. Let's begin. Let's start with pressing an equal sign. Now we'll click on this. This is the sum of the product of each set of z-scores. This is the numerator. And now we divide. So we hit a /. We divide by n. And we'll use the first 10 where we computed n over there and press return. We have an R of 0.66. Now would be a good time to check our work. You never know, we might have made a mistake. And as it turns out, Excel has a built-in function to compute Pearson R correlations. So let's do this. Let's go up to Insert, Function. Let's come down to the statistical category, and it's listed under correlation, or at least under the C's. There it is. And you can see the description. So what we need to do is double click on it now, and it wants two arrays. Well, that just means the two sets of scores. So for array 1, I'll go over to the first data set, click on the first score, actually click, hold, and drag down to the last score. Very good. Now I'll click back in the function builder in array 2, go over to the second set of scores, click on the first score, click, hold, and drag down to the last. And then press return. And what do you know? 0.66. And just to really make a point here, I'm going to go up to column K, and I'm going to choose Format Cells and go back to General so I get all the decimal points. And just notice that we have an exact match of our R values. So that is a good mathematical check of our work. I'm going to do an undo here to kind of go back to where we were before we did our mathematical check. So again, we have an R value of 0.66. So what does that mean? Well, let's remember a few things. First of all, let's remember that an R value can only go from -1 to +1. So as we can see, this is a positive number. So it is a positive correlation, meaning that as one score increases, so does the other. And we also know that 0 would mean that there is no correlation, or values very close to 0. So the question is really, is 0.66 significantly different than 0? And I'm going to save for our next presentation, when we get into inferential statistics, what we mean by testing the significance. So what I'm going to do now is simply kind of cut to the chase about what we actually do. Well, the first thing we have to do is compute something called degrees of freedom. And I will explain in detail what we mean by degrees of freedom in the next presentation. But for now, I'm just going to type df as a label and press return. And in this case, degrees of freedom is simply the total number of pairs of scores minus 2. So I'll hit the equal sign. I will click on this value for n, and then -2, and press return. The next thing I do is look up what is called the critical value of R based on the degrees of freedom. And if my R value is equal to or greater than that critical value, then I can say with confidence that I have an R value that is not 0. So let's see how my R value of 0.66 stacks up. Here's an example of such a table of critical values. And this table can be found in many places. You can find it on the internet. I will share the link to this particular table with you. These are also found in textbooks of statistics. So let's just see. I have a degrees of freedom, in my case, of 8. Just circle that. And I am going to look in the column of the level of significance equal to 0.05. Now in the next video I will explain in more detail why I chose 0.05. But for now, let's just see what value or critical value is at the intersection. 0.6319. So my R value of 0.66 is clearly equal to or above this critical value of 0.6319. So in the case of my data, I can say that there is a positive correlation between these two surveys, meaning that there is a relationship between them such that as scores on one survey go from low to high, they are likely to also go from low to high on the other survey. And the final question we have to ask as a researcher is what conclusions I am going to draw from these results. Such conclusions must be made very carefully, and we must always make sure that we never overstep the data when drawing our conclusions. A reminder that the data I've used in this example are all hypothetical, so I really can't draw any conclusions from them. But if I were to continue with this hypothetical example, I would say that students who are entering this course have some biases associated with online learning. And that might work for me or against me as the instructor. It would work against me if a student has very low opinion of online learning, and no matter maybe how good a job I did as the instructor, they would simply still continue to think that online learning is not as effective. On the other hand, students who have a very positive attitude toward the course might give me more benefit of the doubt when I make mistakes. So you might think about what kind of conclusions you would draw from these data. One last thing before we end, let's make sure we go and save one more time. Okay, until next time.